All right, good afternoon. Uh, Decided that I wanted to record myself solving some programming stuff. Um, I just figured it'd be good motivation for other people to see, and it'd also be kind of fun, help share my thought process, and yeah, just give you a taste into what software development is like. So I'm gonna open up the terminal, and we're gonna go into this repo that hosts my website, and I'm going to launch the site in a test environment so that way I can access it and edit some of the JavaScript on one of the pages. So right now I'm currently working on a Sudoku project, so I'm making sure I'm on the Sudoku branch. If I do make run. So I use Temple, and this first complete message is compiling Temple. And then after that, the rebuilding portion that shows, I believe, Tailwind. And then whenever it finishes, the server starts. And so if we open up Firefox, we can then access the server. So I can go to localhost 8080. That takes us to the homepage. So this is my website, and right now I'm working on this Sudoku project. So on the actual website, if we go online, solvingcodeblog.com, projects, so you can see the Sudoku project is missing, and that's because the branch that I'm working on locally is ahead of the one that's published on my VPS. So let's click on the project link. Okay. And so right now I have a description of the different things that I've done so far. Eventually I'll have to take some pictures and make some media to put in here to help with visual aids. But for the time being, I'm trying to implement these buttons. So currently I have a board. Here I'm going to try and type some letters. Okay, I have a JavaScript function that filters and prevents you from typing letters. Then we can try and type some numbers. I don't know if you can hear it, but I'm trying to type a lot of different numbers, and these input fields only allow you to type one value, which is pretty nice. So if we put in a bunch of numbers, okay, and we click reset, it will get rid of them. And the same could be said for the clear button. The difference between reset and clear is that, say I set a handful of numbers and then click solve, what will happen is the solving algorithm will run, and if you click reset, it should remove the values that were filled in whenever you solved it and give you back the original board that you had. The idea here being that, say you gave it a board that isn't solvable, you can use reset and then you can try out different values so you can solve it again. And this is helpful because you might not want to start from an empty board if you have it mostly full. So reset is working fine. Once you hit solve, it sets the state of the board, so reset will go back to that. So I have clear and reset working. And here is just some error checking. So if you have two of the same number in the same box, essentially in the same 9x9 box, it'll highlight it and then show you the two numbers that are colliding, even if you have multiple. And so here we're showing that these are also, they're not just in the same box, but they're also in the same column, and these are in the same row. Okay. So anywhere there's a collision, it shows you the row and column and box that they're colliding in, and then the actual cells that are colliding. So if I put in other numbers like sevens, you can see that even though they're in this highlighted column, it's not the 7 that's at fault. And if I put another 7 here, this row is bad, but now the 7s are highlighted. So let's say reset. Yes, like one thing for reset, actually, clear. Okay, if we click solve and then reset, perfect. So now if we add numbers, reset should just take us to the last time that we hit solve. So even if I delete these, I can hit reset and they'll come back. But once I hit clear, reset is now emptied. It's invalidated because we cleared and we want to start over. So for this programming session, I have everything implemented for this little program except for the solve button. And so what we'll do now, let me close this tab. What we'll do right now is we can inspect. I want to look at the JavaScript. Let's look at the console. Okay. Cool. So I have the console open, and now what we can do is, let's maximize this. Let's just open up Vim. And I want to open up, let's see, I think it's in JavaScript, Sudoku. Let's look for solve. There we go. So I've done a little bit of work. I haven't really implemented the algorithm yet, but I've done some supporting functions that should make it easier. For example, the isFull and isValid functions are going to be very important. Get Sudoku board is going to be important. And the Sudoku print will be important as well. So these two will be important, isFull and isValid, because it will help us determine if the board is in a valid state or if it's solved. And we'll use this logic to build up our recursive algorithm to then solve the board. One thing I also need to do is, so we're grabbing the Sudoku board here. And what I'd like to do is maybe we have a parameter here called board. And let's set it equal to something. Board equals I haven't programmed in JavaScript in a very long time. Let's see. Null value JavaScript. Yeah, one of the beauties of programming is that you don't really have to be, like you don't have to have everything memorized. You can just Google stuff. The main thing is having the intuition to know what to look for. Right. I know that JavaScript has a null value. I'm pretty sure it supports default values, and we'll figure this out by printing it to the console. Console.log board. Okay. Let's throw a number in here. Solve. Hello. Board equals null. Let's go to the debugger. Did it not reload? Control R. There we go. Interesting. So I think, let's try removing that. We'll reload. Oh yeah, I need to put in a print statement. Console.log running. Okay. Okay, so I think what's happening is this just isn't being called. So what we can do is we need to figure out what is actually hooked up to this solve button. And so what we can do is, I think at the very bottom, so these are functions that I use to draw the red colors on the rows and columns when you put in a bad input. Let's see. Interesting. Let me put full as capital letters. Be valid. Oh wait. Those are variables, my bad. Here we go. Full and valid. We reset. Okay. So this is definitely not being called. I think this is a default state that this input box is put in. And so what I need to do is I need to access the actual HTML that I'm using for this function. So that's going to be in projects. Let's see. Whoops. It's going to be in templates, projects. Sudoku. That one. It's a button. There we go. Sudoku solve. So it's looking for Sudoku solve board. Sudoku solve board. Sudoku solve board. Here we go. Did a hard reset to see if that would fix it. Okay, yeah, okay. So the problem I was getting was actually caching. It was caching whatever was going on here. Like if I put these together. Okay. Earlier this was not changing, and I think something broke and I was caching a value, but we see our output here. That was annoying. So now let's add this board parameter. Console.log. Actually, I don't need a quote. Okay. Reset. Okay. Undefined. And then if I say, was it null? Okay, it still says undefined. Or if I can, let's see. If, let's see, board, null. So I'm just writing a test to see that if I check if the board is null and I didn't pass anything to the function, then it should print out null. If it finds undefined and null as being equivalent. If not, I'll have to try and check for undefined. Okay. So it prints null. Yeah, there's some caching going on because earlier it was saying undefined, but now it's saying null. So the first time it's saying console.log null, and then it logs the board, and in this case, board is null. Okay. Let me delete this for now. It's annoying that I have to keep doing a hard restart because it resets where the things are positioned on the screen. Okay. So that means this is working. It's being set to null instead of undefined like it had been saying. So I can put that back. So if okay. So essentially we're going to make a recursive algorithm that's going to solve the Sudoku board. And when we click the button, we're going to launch this function. And this function is going to call itself a bunch of times. Now the first time the function is called, we don't have a board that we're going to pass to the function. We'll leave it null. And if the board is null, that means we're launching the program. And so we'll grab the board from the user interface. So the getBoard function will read whatever's here, and it will spit out a board object, and we'll catch it in this board variable. I guess we don't need an else statement, just because if the board is not null, then it'll already be set. If it is null, then we can just set it to getBoard. Okay. So now, what is our base case? How do we know we're done? So base case, and then recursive case. So if let's see. So this is where full and valid are going to come in. So now that we have a board, either we grab one from the UI, or this function is called with the board object not being set to null. We can now get whether the board is full and whether the board is valid. Okay. And then the base case will be if full equals true, and valid equals true. Oops. We can return board. Okay. Okay. All right. So we're going to set the board, and then at this point we're going to start our algorithm. The base case is that the board is solved, and this is the simplest possible version of our problem. You're trying to solve the Sudoku board, and it turns out it's already solved. So if we get to this point, we've reached the solution, and we can return immediately. Okay. So now, if we haven't, or if the board is not full, then we've reached the recursive case, and this means we need to run the algorithm again. So what we need to do is we need to fill in a single cell, and we have to iterate through all the different cells, and we'll call this function, we'll create a new board after filling in a cell, and then we'll call solve board on that new board that we create. And if that doesn't make sense, it will pretty soon. So what we can do is we can say, let's see, new board equals board. Actually, I'm not sure if that'll create a reference or if it'll copy it. We have to Google JavaScript, copy object into another variable. Okay, so here, this is a reference copy. So a reference is where instead of storing the actual object in the variable, you're storing the address to that object in memory. And so here the original object, right, we're saying it's equal to this. And when we set copied object equal to original object, what's actually happening is we're holding the memory address of the original object and copied object. So they reference the same exact data. So whenever you change the copied object's name, you're actually going to the location of memory where the original object is, and you're editing the original object's name as well, which is not what we want. Here there's shallow copy, and yeah, so it's not going to get nested objects, which I think is fine. Or arrays. Well, okay, so we have a list. We have deep copy. Okay, so let's test something in the console. Whoops. Here we go. So I want to say list let list 1 equal 1, 2, 3. Let list log. Okay. List 2 equals list 1. Okay. So it looks like we'll need to use deep copy. I can also, let's see, what is structured clone? Yeah, I haven't used JavaScript in a while, so I'm a little bit rusty. So I'll try using structured clone. Structured clone. Looks like I can just call it. Actually, let's test it out in this console. So let's see, list 3 equals structured clone list 1. Okay, list 3 equals 3. Log 1 list 2 list 3. Okay, so that works. So it's very simple. Structured clone of our board. Okay. Create a new board. So now what we want to do is we need to select an empty cell. Empty cell. And then for, I'm trying to think for, I don't know, for 1 to 9, fill in the empty cell with a number and call solve board with new board value. Okay, so now we need to find an empty cell. So what we can do is we can say so we need to get the board first and foremost. So to do that, we can say board.board. And now we need to iterate through the board. So for I'm so used to Python. Let I equal 0, I is less than board.rows. Actually, I'm gonna call it row instead of I. Yeah. Just to make it a little easier to follow. And then we'll iterate through the columns. For call equals 0. Call is less than board.calls. Call plus plus. Look at that. Okay. And then you can say if board.board row call equals, and I think I have empty boards as an empty string, or sorry, empty cells as an empty string, because that's what's returned from the input. So if we've reached an empty cell, we want to save the row and column. That way later we can call the algorithm. Let me think. Let's just say row, let row equals 0, let call equals 0. I wonder if I can omit that. For loop, omit. I don't know. Okay, of According to AI, it looks possible. Okay, so row and column are 0. We're going to run through our loop to set row and column. Oops, break. Actually, let's set them to null. My thought with setting it to null was that, say every value is filled in, we're just going to assume row and column are 0 if they never get set. Does that make sense? Let's see. Yeah, because it could be true and valid is false. Okay. So if we get here, we know that row and column must be set. So if row and col are null, then we are full and not valid. Otherwise, yeah, okay. And I only need to check one of them. If row null, I don't need that space. What we can do is just return false. Okay. So one thing you may notice is that I don't have any, I'm not using autocomplete, I don't have any AI helping me. And when I'm doing personal projects, I try to do it as bare bones as possible. Part of it is that it helps keep me sharp, it helps me remember things, it makes it a lot easier for me to be, I guess, I don't know, it helps me to memorize stuff so that way I don't have to slow down. I'm not waiting to see what autocomplete is going to do for me. It makes it to where I have control. I'm not just waiting what the suggestion is. But whenever I'm at work, I definitely use autocomplete. It's really nice, but this is practice, not profession. Okay. Not full. So we have full and valid already calculated. So maybe instead of this, we can say if full true and valid false. There we go. So one thing I'm realizing is that I'm checking if we're full and valid, and then here I'm checking if we're not full and valid, but in both cases, valid is the one that I care about. If we're not valid, then we just need to return. Because there's no point adding more values into the Sudoku board if the board is not valid anymore. So we can say if valid equals false, then we return false. if the board okay, we're going to return false. So one thing I'm noticing is that here, we're just returning afterwards. So there's no point to nest this in an else in an else statement. So I can get rid of that. And we can dedent this. And you can think of this as a filter. So if the board turn solved board. And then we want to filter out and just return false if the board is invalid. So we return let's see, invalid board if valid false. I always misspell that. Okay. Turn false. Okay, so valid not solved. Oops. So there's three possible worlds we can live in. Either the board is solved, the board is not valid, or the board is valid but not solved. Okay. This one is our base case. Oh, my cat wants my attention. But fortunately, I should be done with this pretty soon. So she'll have to hold on for a little bit, unfortunately. Okay, if the board is not solved, we are going to find an empty row. Oops. Okay. We already know the board does not have an illegal move. Okay. So now we're going to create a new board. And then what we'll do is, we're going to set that empty cell that we found in row and column. And we're going to start filling it with values in a loop. And we'll call solve board on it. And what will happen is, when we call solve board and we've put in a number, it'll check if it's solved or not. And it'll delegate if it's not. It'll find another empty cell. But since we filled in this one, it'll find a new empty cell. And eventually we'll fill up the whole board with numbers. And the original time that we call it, once all the subsequent calls have returned, we can try the next value. And so that's how the backtracking is going to be implemented. Whenever the function pops from the stack, it'll go back to the previous function and it'll try the next number, call the recursive function again whenever it pops back try the next number. And so in this way, we'll be able to keep track of all the different combinations very simply. So for let I equals 0, I is less than 9i plus. Does this even make sense? Sudoku board can have the values 1 through 9, so we need to start at 1. And this is not inclusive, so we can say equals 9. That should fix that. Okay. New board. Board. Row. Call. Equals I. So here we're selecting that empty cell and we're putting in the value I, and then we're going to recall our function. And let's see, forget the name of this thing. Okay. New board. All right. And then we can collect its result. Okay. So we create a new board with the cell filled in. Then we're going to solve, call the algorithm again on the new board that now has an extra value in it, and it's going to return something. If it returns false, that means that we reached an invalid state and we need to try another value. And if it returns a board, then it means that it's solved and we can return the board. Okay. So if result I need to let curse with filled in cell. Okay. So I don't really want to check to see if it's equal to a board because I don't know. I feel like it would just be easier to see if it's equal to false. Oops. XP. So if the result is false, we do nothing. So the result is not false. Then we return the board. Well, we return the result. There we go. Okay. Return the solved board if found. If no solved, I need to make some kind of autocomplete that'll switch those letters for me. It's kind of funny. Okay, so we fill in a cell, and we're going to try every combination of numbers in that cell. And then if the result is not false, so we found a solution, then we return the solution. Otherwise, if we go through every single number, then we didn't find a solution, so we need to return false. That means that we have a valid board. We went through and we kept calling all the different combinations, and after going through every single one, it turns out that it's still not valid. So we need to return false. Okay. So now I foresee one problem. This is getting called when we click the button, and not only do we want to just solve the board, but we also want to set the UI. We want to set that little message box to indicate, hey, a solution was found, or hey, a solution was not found. Fill in whatever results. And so it might be easier if, instead of doing the solution within this function, because this function needs to be recursive, if we break this into a recursive version of this function, and then this function will actually just launch the recursive solution finder, and then it'll delegate based on the results of that what to do. So what does that look like? What we can do is copy this, and let's go to the bottom of the function. Like that. Okay. Call this find Sudoku solution. And then I need to change it here. Oops. Find Sudoku solution. Look at that. And then this one, we don't need a board, right? We'll get and send that. We'll get and set that later. So we'll just run find Sudoku solution result. Okay. So does this make sense? So let result equals find Sudoku solution if result equals false. Log solution maybe. So solution not found, I think that's not harsh enough. We need to indicate that there is no solution. This puzzle has no solution. Not. There is no solution. Else, we can do is let's look for clear Sudoku board. No, reset. So set Sudoku board, original board. What we can do is say solution board equals result So in this case, it's probably doing the same thing, the pass by reference that we checked earlier. Solution board, this exists outside the function. But I think it's okay because we don't edit the solution board directly, and yeah, and the next time we declare a result, I'm curious, so this is locally scoped, and then if we're pointing to this in memory, it may be the case that this is invalidated. But if we just return the result directly into the solution board, that would work. And the solution board should never be set unless it's actually solved. So it's actually solution board. And if solution board is false, there's no solution. Otherwise, set Sudoku board solution board. Okay, and then I think I have a function, I think it's Sudoku print. Sudoku print. And what Sudoku print will do is actually fill in text into that message box underneath the Sudoku board. Sudoku print solution found. So I started using this syntax because I've been programming in Golang, and that's how Golang formats it. Personally, I find it a bit ugly, but I like the consistency of doing the same stuff everywhere. So I don't know. I don't know if I'm going to keep doing that, but I'm just trying it for the time being. So if all things go as planned, this should work. So let's come back here. Okay, perfect. I love errors. 254. Find Sudoku board. Find Sudoku solution. Okay, so it's missing the closing bracket. Yep. So that means this if statement is missing its bracket. Okay. No errors this time. So what if I just click solve? Nice. Board.board row is undefined. What line is this? Find Sudoku solution 280. Board. Board equals null. Board is equal to null. Board equals get Sudoku board. Interesting. Board.board row column. So we've got row and call here. One thing I'm not sure of is It's not getting the column. Board.board row. Interesting. Solve. Object rows calls board. Okay, board. My guess, maybe row is out of the index. Yes, that's exactly what's happening. It's being set to null and going through as null. So this needs to be 0. And earlier I was afraid of this being set to 0 initially, but if we get to this location, we know that the board is valid and that there are empty cells. So it will never be the case that we will not find an empty cell. So it's not a big deal. In fact, we actually... we still need those there. But we don't need this. Okay. If I click solve. Ooh, nice. It's new board instead of board. Okay. New board. Structure clone board. We've got row and call defined up here. New board.board. Say that 5 times fast. Oh, the reason why is I didn't say let. Easy. So reload, solve, hard reload, solve. Okay. New board.board row is undefined. Maybe this isn't a deep copy like I was thinking. Let's try this. Let new board equal new Sudoku board. New board.board equals board.board. And one thing I'll do actually is, well, console.log board redecoration of the new board. Okay, fine. Solve. Interesting. Wow, looks like we've got to use the debugger. So let's put a breakpoint here. Click solve. Okay. So now we can step over. Let's just use step in. What the heck? My guess is I'm running out of RAM. Because I'm on a very old computer. That's really funny. That's really funny. Quit. Memory. No, memory looks fine. I mean, FFmpeg is it's taken up a lot, but 1.5 out of 7, that's not bad. Weird. Huh. Can I open Chrome? What is happening? That's crazy. What did I do? Okay. Cancel. Go away, Linux Mint. Alright. Inspect. It's network performance. Hello. Breakpoints. I've actually not used the developer tools in Chromium. I'm trying to think, is there some type of search bar? Interesting. Console or tools. I want a debugger. Memory inspector, is that what I want? Look at the console. Interesting. I don't know why it took me so long to think to YouTube it. Also, why is Yahoo? That's how you can tell I don't use Chromium. Debugger. Sources panel. Sources. Okay. JavaScript. Here we go. Oh, beautiful. Okay. We gotta go down. Sudoku print. We're above that. Sudoku solve board. There we go. Breakpoint. Solve. Okay. Let's see if things crash. I did step in last time. Oh no. Oh no. Okay, cool. It did it. Okay, yeah, so it's of type Sudoku board. Good. New board. There we go, step. Oop. Step out. Okay. So I've got a new board. New board. An array. All right, it's all empty. Beautiful. Next. Okay. So my question is, what was... So that's new board.board. It looks still empty. So then what is board set to? I don't see board. Hello? Oh, here we go. What are you set to? Okay, it's empty. Yeah, yeah. Oh. Okay. Step out of this. Okay. Let's try solving again. So we will step, step, step. What are row and call set to? Call is 0. Where's row? Row? Okay, row is 9, call is 0. Yeah, row is 9. Call is 0. Oh. Oh, I'm dumb. Okay. Yeah. Okay, so what's happening? What's happening is that I is going out of range. It's going out of scope. Row is just the rows. Huh. Let's see if that fixes it. Maybe the double quotes it was not happy with. Can I run it again? Solve. Step. Step. See how row is 9? That's an issue. Oh, look, it reset back to that. Can't I change it? Okay. So I think one of the issues is that I use double quotes. And we want triple equals. So I was seeing in the debugger that it's single quotes, and so I'm thinking that maybe that's the issue. Let me save that. Reset. I don't know what's wrong with Firefox. I don't know why it won't reopen. My guess is something happened and there's some kind of daemon process running in the background. I'll have to maybe use htop or pgrep to look for it. But in the meantime, let's reload. Yep, so that changed. Solve. How strange. Okay, I'm actually not impressed. I want to put a breakpoint here, actually. So row and color 0. Yeah, row 0 calls a 0. Board, row. So we've got board, row. Sorry, row call. So 0, 0. 0th row, 0th column. Okay. We get to break. Good. Oh. We are not breaking out of both for loops, just the one. Wow, okay. Huh, okay. So we break out, and I guess we just have to check the same condition again. Wow, okay, cool bug. So in this case, we won't have the overflow issue because we will find an empty cell if we were at this point. Wow. Whoops. Let's see, break if empty cell found. Need to check again. Okay, I need to check again because we may have gotten here from searching all calls or from breaking. Okay. That should definitely make a huge difference. Let's reset. I don't think I need to set that breakpoint anymore. Let's solve. Okay, I'm not sure what's going on. Let's check the console. Here we go. 299. Oops. Okay, so it's struggling with this one. New board, row call. Huh. Cannot set properties of undefined. Oh, look. Huh. Okay. Rows call set to 9. Oh, look. 1, 1, 1, 1, 1. It's going through trying to solve it. 1, 1, 1, 1, 1. So it looks like he gets through the entire array, and then I think we're getting an out of bounds error. Like row is set to 9 for some reason. Row or call set to 9. So let's see. My cat is driving me crazy. Column equals 0. Well, column is less than 9. Call plus plus. Interesting. Okay, so we gotta set a breakpoint again. Yeah, I'm not exactly sure why we're getting this 1, 2, 3. Yeah, rows calls array. Each array has 9 elements. Yeah, what is I equal to? Undefined setting 9. 299, 300. Cannot set properties of undefined. Setting 9. We have let I equal 1. Plus and equal 9, I plus plus. Yeah, we need to use the debugger. Sources. 299. Oh, shoot. Let me hard restart. Okay. So if we look at the console sources, set a breakpoint here. Solve. Okay. 10. So let's look at new board. Rows, calls, okay. Okay, so new board is empty like we expect. And what we want to see is have a value, the value 1 to be stored here. So let's step. Okay. I is 1, good. Less than equal to 9. Board, new board.board. Row call. Row 0, call is 0, equals I. How strange. New board. So let's step over. Okay, yeah. New board. Let's step into here. Okay. Board is equal to null. Oh, check this out. Full valid, original board dot is full, original board dot is valid. That needs to be board, doesn't it? That needs to be board. This is the original board. Look at that. What are we looking for? Original. I think I need to go up. Here we go. Okay, so we're checking if the current board is full, if the current board is valid. Okay, I think that's why we're getting issues. Let's reload. Solve. Next, next, next. Yeah, because we were getting issues here. Step into. Next. Next. Nice. Nice. False. So full is false, valid is true, which is the case. This is empty. Okay. Check out this board. So next, next. Yeah. Yeah. So see how he broke out and column is equal to 1? Look at our board. The first column is 1. The second column is blank. Or sorry, the second column, but the first index of 1. That's this column, index of 1. Sorry if that was confusing. Okay. I should expect another 1 to be here. And we're going to go into this function and it should return false. Yeah. Check it out. It returned false and then it filled in a 2. So let's remove this break statement. Let her run. Let her rip. Oh, shoot. Oh no, it broke. What happened? Solve. Ooh, that's not good. Okay, so it looks like well, let's put a break here, rerun it. Now I just gotta watch these values and see what they become. So let's run. 3, 4, 5. Hello. 6, 7, 8, 9. Oh, weird. Oh. No, it got through it. But it only filled in. It only filled in the column, I think. What are these two errors? Hello? Console? Okay, we'll run it again. Whoops. JavaScript. Okay, run. Eight. 9. Okay, so check it out. I think okay, look. Here's the call stack. So we're 1, 2, 3. Yeah, so we're 10 deep. The original one sets the board. We call it on an empty board, and then we filled in 9 values. So there's 10 of these, and we're in the final one. And I think this one it crashes, so we need to pay very close attention. Why does it crash? So let's step into, and what I would like to see is for this one to become a 1. Step into, okay. Less than equal to 9. So I think in this case, I should be equal to 1. Yes. Because this is a new function call. So this is our first time coming through here. I is 1. It's certainly less than 9. Okay. So now we're looking at our board. Now what is the row? Okay, look, column is equal to 9. That's an issue. How did we get there? Look, row is 9, col is 9. Row is less than 4.rows. Yeah, okay, so the issue is this again. What's happening is column gets passed here, and column gets set to 9, and then row gets through here, and row gets set to 9. Oh, that's really strange. Huh. We need to look at this again. So let's set a breakpoint. Hit run. Yep. We fail. Okay. Run it. We're in a new call stack, I think. Actually, no, same one. We can keep the breakpoint there. So call is 0. Where's row? Row is 0. Oh, that's annoying. Okay, it just hasn't been set yet. So call is 1, row is 0. Okay. Call 3, call 4, call 5, call 6, call 7. So we need to pay attention to column 8. Column 8 means that we are, let me see this a little better. Column 8 means that we are looking at this final column in the Sudoku board. So that's the 8th index. So let's continue. And now here, we need to be a little bit more careful. Column is 0. Okay. All right, so we're iterating through the columns. Four, 5, 6, 7, 8. Okay. So we are now at the final column in the first row, and what I would like to see is for row to increment by 1 and column to get reset back to 0. So maybe what's happening is that because these are defined outside, it's not getting reset. I think that's exactly what's happening. So check this out. Row equals 0. I thought I was being smart. Actually, I need to edit it here. Yeah, I'm not resetting them. Row equals 0. Call equals 0. maybe empty cell row, empty cell column. Okay. Empty cell call equals call. Actually, we'll set them in the same place. Empty cell row equals row. Yeah, I thought it was being smart by removing these because I needed access to them after the for loops went out of scope. But what I didn't realize was that this is needed to reset them. I didn't think about that. Yeah, so that's a big learning moment. If you need the value of this, it's often easier to just create a different variable, set it from inside here, it'll be fine. So now here, empty cell row, empty cell call. Okay. All right. Solve. Hit play. Hit play. Ooh. Look, lowercase. What the heck? There we go. Solve. Okay. Goes through. Let me remove these. Oh, look at that. Another error. Look. Let row. I did it again. Look at that. Let row, let call. Crazy mistakes today. Solve. Here we go. 289. Okay, I clicked solve. Let's look at the console. Some errors happened. Cannot read properties of null. Find solution at 300. Huh. Weird. That's down. Okay, that's fine. Huh. This is why I'm glad to have a debugger. Empty cell row, empty cell call. So what's happening is we're getting through. I'm trying to think, how does this happen? I mean, they default to 0. I'm an idiot. Look, we're breaking before we set it. Oh my gosh. There we go. Look at that. Every mistake in the book. But it's okay. All right, we have a solution. Beautiful. Solution found. So now what if how could we break this to make it not work? Wow, very cool, very cool. So what if we put a 6 here and then remove that 6? All right, no solution. Look at this, no solution. And if we reset, nice. Oh, look. Wait, 9, 9, solve. So because I created this new function, I actually reset the solve behavior. So when we do Sudoku solve board, we need to say Sudoku solve board original board equals Sudoku board. I think it's get Sudoku board. Yeah. Okay. So we're going to set the original board to get Sudoku board. So we do that. Solve, reset, solve, reset, solve. Okay, so now what if we do this? Solve, reset. Beautiful. So now let's delete a bunch of stuff. I'm just trying to delete enough to make sure that this reset is going to work properly. And then also I want to give it a bit of calculating to do. I want it to be difficult. Like maybe there's multiple paths to solve it and I just want it to pick one. I don't know. I'm trying to make the case complex enough to hopefully trigger any kind of edge cases. Honestly, I don't think there's any. Yeah. So look at that. Isn't that crazy? Yep. Wow. Cool. Solve, reset. Solve, reset. Clear. 8, 8, 9, 9, 7, 7, 7, 7, 5. Now that more values are filled in, I'm just trying to randomly put these in, but it's getting harder and harder to make them not collide. Okay, check this out. I'm going to try and put in an error. Okay, check this out. So this should not be a valid Sudoku board, and the reason why is because in here, a 1 has to be in this column or this column, but there's already 1s. So let's see. No solution. Beautiful. But if I get rid of that one, no solution still. No solution. Interesting. I wonder when I'll get a solution. Solve. Solve. Oh man. Solve. Oh, this one's thinking for a long time. It didn't find anything. Thinking a long time. There we go. Okay, cool. So that's it for this session. Next session, what I want to do is the values that are filled in by the solution, I want those to be blue. I want those to be blue. And then, I'm trying to think. I also want to have a loading screen or a loading bar. That way when it freezes up like this, you get some feedback. But for now, I think this session is done. That was pretty good. I'm happy with that. So let's save. Add status. Add. Okay. Added Sudoku. Let's see. I was kind of bad the last few times I programmed. I was out with friends, so I was very distracted, and I did not make any commits. So this one is going to be huge. Distracted programming bad. Just don't do it. Beautiful. All right. We can close out of that. Close out of that. And I'm using FFmpeg to record the screen as well as the audio. It's because my computer doesn't have a GPU. It's really old. It's an old ThinkPad from 2010. And so FFmpeg runs on the CPU, which is kind of interesting, in case you wanted to know.